I don't know if it's good news or bad news or if it's just news, but we're not going to have our exam on Wednesday. Instead, we're going to have that on Friday. So we'll switch. On Wednesday, I'm going to introduce your project for the semester. And we're also going to have some visitors who weren't able to come on Friday. They're only available to come on Wednesday. So it's still an important class meeting, but the exams move to Friday. Now, on that exam, I'm going to provide a formula sheet for you to use that includes the equations, like P/A, F/P, all the time value of money equations. The formula sheet that I provide is also going to have any factor tables that I ask you to use. So you do not need to prepare an equation sheet for the exam. There will be one problem where you use Microsoft Excel. Now, look at the computer you're at, because I know some of the machines in here don't work. So don't sit at one of those unless you bring your own laptop for the exam day. And I know a lot of you do prefer to use your own laptop, and that works out great since some of our desktop computers aren't working. But we will need Microsoft Excel for the exam. Now the other thing, homework 6, future worth and annual worth analysis, that's still going to be due as originally scheduled on Wednesday. Any questions regarding the announcements? Okay, so today we're going to continue the analysis. Remember, what we're doing is we're applying a method to make decisions. We did the future worth method and then turned that into future worth analysis by comparing options and applying a decision criteria. We did the same thing with future worth, where there was the future worth method, and then the future worth analysis is comparing alternatives and applying a decision criteria. So today with annual worth analysis, our decision criteria is that when you take the cash flows to an annual basis using the MAR, then you choose the alternative that gives you the highest non-negative annual worth. So it's the same kind of trend that it's used before. We're choosing the alternatives only that are non-negative, because if it's negative and we were discounting or compounding at the MAR, the M in MAR stands for minimum. And so if you can't get a profitable project when you're applying your minimum acceptable rate of return, then that tells you to reject both the alternatives, potentially. So here's what we do in annual worth analysis. Now here's a sample cash flow. You'll notice that some of what's in this cash flow is already on an annual basis. And so it looks like we have an annual series where there are 8 annual payments of, let's assume these are millions, so 0.9 million. So 900,000 is repeating 8 times, so that's already an annual. But then there are these single elements that aren't already an annual. We have 8 million at the present. We have 5 million at year 1 and 0.5 million in revenue at year 8. So in annual worth analysis, what we're doing is we're taking all that to an annual basis, and then for more than one option, we'd be comparing the two and seeing which one is best. All right, so when we do something like this, obviously we don't have to do any conversion to the 0.9. I mean, once in a while someone will take this annual series back to the present and then back to an annual series again. And there's no need for that round trip. The 0.9 is already an annual series. So what you would have to change is you'd have to change, for example, the 8 million at the present. You would do find A given P for that one. So you do find A given P at whatever the interest rate is, and N equals 8. What about this? It's going to be a 2-step process to turn this into an annual series. Anybody want to guess what would be the 2 steps? Go ahead.
You probably make it into a present or future worth.
Okay.
Use the A over P or A over F.
Exactly right. Yeah, so he identified correctly that you can either take it to the present and then find A given P, or you can take it to the future and then find A given F. But from where it is right now at year 1, we don't have any function that takes something from year 1. If you just did find A given P and assumed that this was P, then you'd be skipping over contributing to year 1 of the cash flow. So it would only send that amount to years 2, 3, 4, 5, 6, and then you wouldn't have a single uniform cash flow for the entire diagram. So it's a two-step process. And one of the things to pay in mind is that maybe it would be simplest if don't take this present value out to the annual series until you've combined it with all the other amounts that are going to P as well. So if we take this 5 first to year 0 and combine it with the 8 that's already at year 0, then we can take the combined amount to an annual series and save a step rather than spreading it out over the annual series in 2 separate calculations. Okay, now this one that's at the future, it's a single step there because we do have functions that would find A given F, and the form of those, find A given F, is it assumes that the last year is the same year, the last year of the annual series is the same year that the future amount occurs. So if you do find A given F for n equals 8, then it's going to take this single amount and spread it equally over each of these 8 years, including year 8. Now, one of the nice advantages of the annual worth analysis is that we don't have to apply LCM, contract services, or early termination. In other words, the problem that we sometimes had with different durations of alternatives, like with the future worth method and the present worth method, the annual worth analysis automatically takes care of that. And so it is okay to compare alternatives with a different useful life when you use the annual worth analysis, because what you're doing is you're just expressing it in terms of each year, and you're automatically assuming that the alternative is repeatable. So you can compare items with a different useful life when you do annual worth analysis. Even though you're only calculating it for a single cycle, it's automatically assuming, the annual worth analysis method automatically assumes that the LCM is going to be applied. So if you've got something that's 6 years and something that's 8 years, when you use LCM analysis, you're assuming that those could be repeated enough times that they eventually terminate in the same number of years. So therefore, you're assuming that it will be repeated and that the cash flow amounts are the same in subsequent cycles. Any questions about any of this stuff so far? Here's an interesting idea. What if you got paid $50,000 a year forever? Not just for the rest of your life, but for the rest of the universe. What if you or your heirs got $50,000 a year forever? So the question is, how much would that be worth in an equivalent amount now, where you've got some interest rate? If the payments continued till infinity. So if the payments continue to infinity, you might be tempted to think, well then, that means the present value is infinity, because the payments are never going to end. But that actually wouldn't be accurate. And the reason why is that, remember, future amounts aren't worth very much, especially amounts that are way in the future. And so that $50,000, 10,000 years in the future, it might as well be worth a penny now, because you're discounting it so many years to get it to the present. So there is an actual finite value for the present worth of an annual series that continues forever. And the equation is much simpler than you might expect. To find the present worth of an annual series that extends forever, it's simply A, the amount, divided by I, the interest rate. So it represents the interest on a perpetual investment. So this example of $50,000 a year, if your interest rate is 10%, then the value of that investment would be A, the 50,000 divided by I 0.10, and so the present worth is simply 500,000. And the way that you can think about it is, what if you needed to be the person who was paying the money? What if you were on the hook to pay someone $50,000 a year forever? How much would you need to put into the bank now so that the bank would continue to pay out that sum to them each year? Well, if it's a 10% interest rate that you're getting at the bank, then the 10% interest on the principal would be $50,000, and then that interest would go to whoever's receiving that annual payout. So you could give someone an infinite income stream for just 10% of that annual amount, assuming 10% is the interest rate. Now remember, the key thing here is that it doesn't have infinite value, because the value of 50,000 many years in the future isn't going to be nearly the same as 50,000 in the first year. So the purchasing power is going to decrease over time, even though the amounts themselves are the same. So this is called capital cost, a capitalized cost analysis. And the flip side of this, now this is where we're finding out the present value of an infinitely long annual series. The flip side of that is that some investments really do last forever. So if you pay a certain amount now, then the thing that you buy or the thing that you build may be long enough lived that it's considered a permanent investment. So here's a picture of the Brooklyn Bridge, just as an example of something that's very old, and it's not anywhere near being worn out or discarded. It was built well, and it'll last a long time. And so what would be the annual equivalent if the item is considered a permanent investment for a certain present amount that you spent to have it constructed? And so the way that we would do that is we would simply rearrange that previous equation and solve for A, the annual amount, by multiplying the present worth by the interest rate. And so if you spend a certain amount at times 0, then A represents how much do you have to recover each year in revenue to cover that initial purchase price. So if you spent a certain, $100 million to build the bridge, how much revenue do you have to collect each year to cover that cost? Well, it's essentially the present amount multiplied by the interest rate would tell you the capital recovery. Capital recovery, this phrase capital recovery, means the initial amount that you paid, how much you have to receive in revenue each year to justify that expense. Okay, so any questions about either of these two slides, the capitalized cost or capitalized recovery? Here's where things get a little bit more tricky. This was for a perpetual investment. So you notice here's the infinity symbol. It's easy to calculate the annual amount if it lasts forever. Because if it lasts forever, there's no salvage value. Salvage value is when you are selling an item for scrap, or maybe on the resale market at the end of some period. But in the case of a bridge or a dam or a canal that's been dug, it lasts forever, and so you're never selling it back for scrap. Some items, though, we do salvage at the end of their useful life, and so we may see a cash flow diagram that looks like this, where in time 0, you're spending a certain amount to purchase or build the investment, and then at the end of its useful life, you sell it, and so you have an inflow in that last year. And then what you're wondering is, taking the initial purchase price into consideration and the ultimate disposal value, how much would you have to receive each year to cover the difference? And so here the capital recovery, you'll notice that here it's showing the arrows are down because the initial purchase price is generally larger than the salvage value. It represents the difference between the two, and so when you calculate the capital recovery, you're estimating how much revenue is needed in order to recover the difference between the initial purchase and the ultimate disposal of the item, taking into account the time value of money. So this salvage value in time 0, not only is it going to be smaller in absolute terms, the number of dollars will be less, but also the value of those dollars isn't so large because it's in the future compared to these really valuable dollars that we spent at time 0 when prices were lower and money had more value because it hadn't yet been eroded by the effect of inflation, inflating prices. Here's the formula for how to calculate capital recovery. And it's the same thing that we can see from the cash flow diagram. How do you calculate this unknown annual series? Well, you take P and convert it to A, and you take the F and convert it to A. And that's all this formula says, is it says calculate the capital recovery amount by taking the present value and finding the annual equivalent of that. And then the salvage value, which is at the future, you would multiply that by the factor for A/F. So you're finding A given some future amount. Now one last thing. What about the signs? You'll notice that here there's a negative sign in front of the first collection of terms and a positive sign for the second collection of terms. So why the difference in signs?
You would be, like with the present value, you'd be paying for it.
Good.
And with the future value, you'd be getting money from it.
Exactly right. Yeah, so he noticed that in the present, you're spending money. In the future, you're getting money. So this capital recovery has to have the sign considered, because what you're trying to estimate is how much revenue you have to receive to cover that cost. And so the value of the salvage at the end is going to decrease how much annual revenue is required to cover the initial expense. So you're trying to recover the first cost and a stated rate of return when you've also taken into account the salvage value. All right, so here is today's first problem for the in-class exercise. That same cash flow diagram that we saw before, we're going to consider it at the 8% rate. The 8% table's on the back of the paper. Okay, I've got my strategy up if you want to check and see. What I did was I labeled each one of these non-annual amounts. So anything that needs to be converted, I've put a label on. So there's this amount at A, there's an amount at B, an amount at C. So those are the things I'm doing the work on. And then here, I'm just kind of in a bulleted list explaining what the steps are going to be when I actually do the calculations. So I'm putting on the screen the calculation themselves now, if you want to take a look at that. Oh, too much. I think it's a good habit to not only write down the amounts, but also write when the amount is. So, for example, this 5 million. The 5 million is at year 0, but then if you write, once you've done the conversion and taking it to year 0, if you emphasize that it's this negative 4.6 million at year 0, then at the very end when you're adding things up, you'll only add up the amounts that are at year 0 before then you find A given P. So sometimes the mistakes that you get along the way can just be like adding in the wrong amounts that aren't at the time that you have in mind. But what you should get is 3.05 million in outflow is the combined annual worth. Once you finish this one, then start with the question on the back, trying to find the capital recovery for a septic pump truck. In case you need to see the other problem solution, I'll leave that up for a few more minutes. I'm going to put the solution to the second problem up on the screen.
Yeah, it's a free multiple choice. That's not bad though. I mean, all things considered, that's like 8% of our grade for free.